Okay, this is going to be a bare bones presentation of these graphing examples. Okay, there is no goal of production level pristineness for broadcasting or anything like that. If I make an error, I'm just going to erase it and move on. Okay, you may hear, this is being recorded at home, you may hear the noises of our house, either family members chattering or the train that's only the train tracks that are only a few blocks away, or emergency sirens, because every time there's an emergency, they for first responders, they blare out the fire sirens so that the first responders will turn on their communication devices. Okay, so those are a number of things you may hear between now and when this is over. Okay, so we're going to sketch y equals 8 to the x power. Okay, to make sure that that's clear, the x is in the exponent. Now, I don't have any, I'm going to show this the same way I show the first day of class. We'll just go integer by integer, one at a time. Left to right. -1, 0, and 1, as this represents the x-axis and this represents the y-axis. So if x equals -1, y equals 8 to the -1st, which is 1 over 8 to the first, which is 1/8. So this first point is -1, 1/8. If x equals 0, y equals 8 to the 0th power, which is 1. So this point will be 0, 1. And this point is y equals 8 to the first power, which is 8. So that gives me 1/8. So, -1, 1/8 is a half of a half of a half. So -1, half of a half of a half, about right here. Zero, 1, left, right, nothing, up, down, 1, and 1/8. Okay, don't hit the x-axis because there's no way you can take 8 to a power and get 0. Okay, that'd be y equals 0, so don't hit the x-axis, avoid it. Otherwise, draw a curve that hits all 3 points. Again, just do the best you can. We're not computers. We do not expect computer level accuracy. Okay, so that's graphing the way we did the first day of class. I'm going to start showing some shortcuts for some standard types of equations, starting with quadratic functions. This is y equals x squared plus 4x minus 5. So, my first order of business would be to find the y-intercept. This is where the graph is going to cross the y-axis. It'd be 0, it could be 0, whatever. Okay? So with the y-intercept, x equals 0. Okay, somewhere along this entire thing is x equals 0. So if x equals 0, y equals 0 squared plus 4 times 0 minus 5. 0 to any power is 0. 0 times anything is a 0. 0 plus 0 minus 5 is -5. So we have 0, -5. I'll go ahead and plot it. Left, right, nothing. Up, down, -5. So down 5 to -5. Next, I'm going to do the x-intercepts. This is going to be where the graph crosses the x-axis. When that happens, y is 0. And since this equals y, the quadratic has to equal 0. Okay, so I got x and x. The pair of factors of negative 5 that have to positive 4 are positive 5 and negative 1. So I have x plus 5 equals 0, x minus 1 equals 0. Subtract my 5, and x equals negative 5. So this x-intercept would be negative 5, 0. Here I will add 1, and x equals 1. So this x-intercept would be 1, 0. X and y coordinate 0. X and y coordinate 0. I'm going to go ahead and plot them. That's negative 5, 0. That's 1, 0. Now, I'm going to do all integers between. I'm going to do all integers between. Okay, I'm going to move this down so it's a little clearer. Okay, I'm going to do all integers between. So, here's negative 5 I'm going to start with. Okay, here's negative 5. I'm going to start with negative 4. I'll also do negative 3. Okay, I'm going to move this board. I will also do x equals negative 2. I'm going to move this up. I'm going to move this up here. Okay, I'll do x equals negative 2, x equals negative 1, and x equals 0, which is already done. That would give me all integers that are between the x-intercepts. So x equals negative 4. Y equals negative 4 squared plus 4 times negative 4 minus 5. So that will be 16 minus 16 minus 5. 16 minus 16 minus 5. 0 take away 5 is negative 5. So this point will be negative 4, negative 5. X equals negative 3. Y equals negative 3 squared plus 4 times negative 3 minus 5. That's going to be 9, because negative 3 times itself would be 9. 4m minus 3 will be minus 12, minus 5. Negative 3 minus 5 is negative 8. So this point is negative 3, negative 8. X equals negative 2. Y equals negative 2 squared plus 4 times negative 2 minus 5. That would be 4. That would be minus 8 minus 5. Negative 4 minus 5 is negative 9. So negative 2, negative 9. X equals negative 1. Y equals negative 1 squared plus 4 times negative 1 minus 5. 1 minus 4 minus 5. Negative 3 minus 5 is negative 8. I have negative 1, negative 8. Okay, and 0 was already done. So all I need to do is put the curve through. It's a parabola. All right, so that's what we're going to do. Again, we shouldn't expect computer level accuracy out of ourselves. As you can see, the x-coordinate of the vertex is halfway between the x-intercepts. 3 over, 3 over. All right, next page. Y equals x squared minus 7. We'll start with the y-intercept. At the y-intercept, x is 0. So y equals 0 squared minus 7. 0 minus 7 is negative 7. 0, negative 7. X-intercepts. Y is 0. And since this is equal to y, the quadratic has to equal 0. We're going to use the square root property to solve this. So I'll add 7. And so x squared has to equal 7, requiring that x equals plus or minus the square root of 7. So, my x-intercepts are negative square root of 7, y-coordinate 0, and positive square root of 7, comma 0. Okay, this isn't very useful for graphing purposes, so I'll put a decimal approximation below the square root of 7. Approximately 2.65. So negative 2.65, positive 2.65. So a little bit less than negative 2.5, a little bit more than 2.5. I will also do all integers between. I'm going to do all integers in between. So we have negative 2, negative 1, 0, which is already done, 1, and 2. So if x equals negative 2, y equals negative 2 squared minus 7. 4 minus 7 is negative 3, because negative 2 times itself would be positive 4. 4 take away 7 is negative 3, so that's negative 2, negative 3. At x equals negative 1, y equals negative 1 squared minus 7. Negative 1 squared is positive 1. 1 take away 7 is negative 6. I have negative 1, negative 6. X equals 0 is already done. It was 0, negative 7. Okay, I suppose I could make it look a little neater at least. At x equals 1, we have y equals 1 squared minus 7. 1 to any power is 1. 1 minus 6. 1 minus 7 is negative 6. So we have 1, negative 6. And x equals 2. Y equals 2 squared minus 7. 4 minus 7 is negative 3. We have 2, negative 3. All right. Next page. We have y equals x cubed minus 5x squared minus 4x plus 20. So, I'm going to start with the y-intercept. At the y-intercept, x equals 0. So y equals 0 squared, 0 cubed at this time, minus 5 times 0 squared minus 4 times 0 plus 20. I end up with 0 minus 0 minus 0, minus 0 as I said. I should have written 0 plus 20, which leaves me the 20. 0, 20. Okay, I'll go ahead and plot it. Zero 20 is up here. Next, I'm going to do the x-intercepts. At the x-intercepts, y is 0. And since y equals that cubic, the cubic needs to equal 0. So, it's factorable by grouping. I'm going to take an x squared out of the first two terms. That would give me x minus 5. And taking negative 4 out of the second two terms would also give me x minus 5. So we have x squared, x minus 5. Third term is negative. I'll take it out. They're both divisible by 4. Negative 4x divided by negative 4 is x. 20 divided by negative 4 is minus 5. Which gives me x squared minus 4 times x minus 5 equals 0. Which gives me x squared minus 2 squared. So that'd be x plus 2, x minus 2, x minus 5 equals 0. So, x plus 2 is 0, x minus 2 is 0, and x minus 5 is 0. Subtract 2, x is negative 2. Add 2, x is 2. Add 5, x is 5. So this point will be negative 2, 0. This will be 2, 0. This will be 5, 0. I will also do all integers between. I'm going to do all integers in between. So -1. I might want to use some space. 0, which is already done. It was the y-intercept. Suppose I'll do 1 on that side. And then I'm going to switch over to 3 over here. And then 4 down there. Okay, so y equals -1 cubed minus 5 times -1 squared minus 4 times -1 plus 20. -1 cubed would be -1. -1 squared is 1. 1 times -5 is -5. That's going to be plus 4 plus 20. So, -6 plus 4 is -2 plus 20 is 18. So I have -1, 18. At x equals 1, y equals 1 cubed minus 5 times 1 squared minus 4 times 1 plus 20. 1 to any power is 1. 1 times anything is the anything. So that's going to be 1. 1 times minus 5 will be minus 5 minus 4 plus 20. -4 minus 4 is -8 plus 20 is 12. 112. Okay, at x equals 3, y equals 3 cubed minus 5 times 3 squared minus 4 times 3 plus 20. That'll be 27. 9 times minus 5 is minus 45. Minus 12 plus 20. -18 minus 12 is minus 30, plus 20 will be -10. So that's 3, -10. Okay, just for my own peace of mind, I'm going to check that. Yeah, hold on. Yeah, minus 10. At x equals 4, we have y equals 4 cubed minus 5 times 4 squared minus 4 times 4 plus 20. So that'll be 64. 16 times minus 5 is minus 80. Minus 16 plus 20. So, -16 minus 16. Oops, let me go ahead and do the 3 -10 as well. 3 -10. And then -16 minus 16 is negative 32 plus 20 is -12. So that'll be 4, -12. All right. And then we're just going to do the best that we can to draw this. We should just do the best that we can to draw this. Obviously, I went too far over if I hit one of the grid lines. Okay, again, we're going to do the best that we can here. All right. Next page. We're going to switch to absolute value equations. I'm going to do this two different ways. One's easier than the other, but you need to see where it comes from first. Okay, these are going to be V-shaped. And this one is the absolute value of x plus 12 minus 14. So they're V-shaped. You're going to have a vertex. That's going to be the low point of the V. Okay, they should look like this, or they should look like that. These are shaped like this, or they're shaped like that, one or the other. The vertex is the point that's either on bottom or on top. So the vertex is the location of where your argument equals 0. The argument of an absolute value expression is what you're taking the absolute value of. So in that case, it's x plus 12. Subtract 12, and x is negative 12. Now, if x is negative 12, y would equal the absolute value of negative 12 plus 12 minus 14, which is the absolute value of 0. 0 take away 14 is negative 14, so the vertex is negative 12, negative 14. So negative 12, negative 14. Now remember, they're going to be V-shaped. So we'll start with the right side. Right side. Right of the vertex would be x equals negative 11. So y equals the absolute value of negative 11 plus 12 minus 14, which gives me the absolute value of 1 minus 14. 1 minus 14 is negative 13. So this point, the point immediately to the left, will be negative 11, negative 13. Sorry, to the right will be negative 11, negative 13. Next, the left side. Left of the vertex, if that's negative 12, x equals negative 12, it would be negative 13. Y equals the absolute value of negative 13 plus 12 minus 14, the absolute value of -1 minus 14. The absolute value of -1 is +1. Same y-coordinate as before. As I said, these are supposed to be V-shaped. X, Y. All right. Remember, it's supposed to be V-shaped. Okay, so if you notice, it's the y-coordinates on each side were the same. So what we'll do on the next page is we'll do the right side and just mirror it on the left. Okay, so here we go. Y equals the absolute value of x minus 13 plus 11. And again, the vertex is going to be located where the argument equals 0. So where x minus 13 would equal 0. Add your 13, and x equals 13. So y would equal the absolute value of 13 minus 13 plus 11. 0 plus 11. The absolute value of 0 is 0. 0 plus 11 is 11. So 13, 11. Next, we're going to do the right side. Immediately right of x to x equals 13 is x equals 14. Y equals the absolute value of 14 minus 13 plus 11. The absolute value of 14 minus 13 is the absolute value of 11. Sorry, the absolute value of 14 minus 13 is the absolute value of 1. The absolute value of 1 is 1. That's 12. So this point will be 14, 12. Left side. This was 1 over y-coordinate 12. This also will be 1 over y-coordinate 12. So 1 over same y-coordinate. So over 1, y-coordinate 12. Over 1, y-coordinate 12. Okay, I'll show you that again. Okay, in case you missed it. This was the vertex. This was 1 over y-coordinate 12. We're going the other way. 1 over y-coordinate 12. All right. Moving on. We're going to do this line using two different methods. One method is we're going to use the intercepts. So at the y-intercept, x equals 0. Now if x equals 0, y equals 10/9 times 0 minus 14. Anything times 0 is 0. So 0 take away 14 is negative 14. The y-coordinate is 0, negative 14. Next, I'm going to do the x-intercepts, or the x-intercept. That is where y equals 0. And since this equals y, that is where 10x, or 10/9 x minus 14 equals 0. The LCD is 9. I'm going to multiply everything by it. So, the 9's cancel, I end up with 10x minus 126 equals 0. Add 126, and 10x is 126. I'm going to copy this over here and divide off the 10. And x equals, top and bottom are divisible by 2, 63/5. So the x-intercept is 63/5, 0, because the y-coordinate is 0. That's not very useful for graphing purposes, so I'll just tell you that's 12.6 as a decimal. Okay, so that'd be about right there. I'm going to put a point, I'm going to put a line that connects them. Since that's going to be a straight line, that's linear. Alright, looks like there's a bump there. I really don't like that. Okay, I do want my lines to, I do want this line to look like a straight line. Okay. For example 7b, I'm going to use the same equation, but we're going to use this method. The equation of a line could be written as y equals slope times x plus the y-coordinate of the y-intercept. If it's negative, if it's a subtraction, then it's a negative y-coordinate, or a negative y-intercept. So this means that the y-intercept is 0, negative 14. I'll go ahead and plot it. All right. Now, my slope's informal name is rise over run. So that would be 10 over 9. Now, I write it, I think of it, I'm starting to say rise over right. Okay, because that always refers to run right. So rise over right is still 10 over 9. So that means we're going to rise 10 from the y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to go right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, sorry, I made a mistake. Okay, it's rise over right. So I need to rise 10 from the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I need to go over right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. It should hit the same points as the previous line. Okay. You don't need to be this particular about it, but I'm going to be. For myself, it should go through the same points as the other line did. That's better. Okay, so as you can see, as you should be able to see, both points go through 0, both lines go through 0, negative 14. They also go through 9, negative 4. 9, negative 4. Okay, they go through the same points. I just used two different points to get to two, here I used this method to get all the points. Here I used this method to get the same line. Okay? Next page. On the next page, I'm going to use this method exclusively. So here, the y-intercept is 0, 13. The slope, which is your x coefficient, the slope equals rise over run. That's the informal name for it. I'm going to move the negative to the numerator, so that'd be negative 7 over 11, which to me I call rise over right, which should be negative 7 over 11. A rise of negative 7 is actually a drop of 7. Okay, a rise of negative 7 would be a drop of 7. So 0, 13. And then from there, I'm going to drop 7, because a rise of negative 7 is actually a drop of 7. I'm going to go over 11. So drop 7. 1, 2, 3, 4, 5, 6, 7. Okay? I'm going to run right 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. X coordinate 11. I'm going to put my line through. All right. Next page. I'm going to use the same method. So here, the y-intercept is 0, 14. I can go ahead and plot it at any time. This time I'll do it now. This one, this is slope. That equals rise over run. I got negative 16 over 1. So that's rise over right, which is negative 16 over 1. a rise of negative 16 is actually a drop of 16. So, from here, the y-intercept, I will drop 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I'm going to go over the right 1. This time I'm going to use a different method. I'll use 0 and 1. It should still give me the same line. Okay? I have to admit I don't like the way that line looks, so I'm going to try it again. Yeah, if I'm going to do that, I have to have the ruler pushes the pencil out to the left a little bit, to my right a little bit. Okay, that's better. It's not great, but it's better. Okay. Now for the second method, I'm going to start over. Second method, x is 0 and x is 1. So, if x equals 0, y equals negative 16 times 0 plus 14. 0 plus 14 is 14. So 0, 14. If x equals 1, y equals negative 16 times 1 plus 14. Negative 16 plus 14 is negative 2. So we have 1, negative 2. As you can see, it's the same line. Okay. Finally, sketch the horizontal line. Y equals negative 11. Okay, so if x equals 0, y equals negative 11. So 0, negative 11. If x equals 1, y still equals negative 11. So that would be 1, negative 11. Okay. I'll do that again, okay, since the bottom wasn't visible. Just going to do it again from scratch since the bottom wasn't visible. Okay, so if x equals 0, y is negative 11. So that's the y-intercept. 0, negative 11. Now if x equals 1, y still equals negative 11. So that's 0, negative 11. That's 1, negative 11. And that takes care of that.